Hello everyone. Today I'm gonna pretty much just show you how to fly the A321 by Tolis. And this is actually gonna be kind of a beginner video. I'm just gonna start from cold and dark, going through the departure, cruise, and approach and landing. And I'm gonna just explain everything that I do in detail, and everything I come up with, everything I've learned in the past month since I started flying on X-Plane. So if you're new to X-Plane or want to learn something about the A321 or in general just want to see if there's something you didn't know already, this video is for you. Um, I'm still kind of new to flying airplanes. I started last year August, so this is not gonna be a perfect video without any flaws. Some mistakes I'll realize, some I won't probably, so it's just for fun. You probably learn something, especially if you're new, so stick around. So first thing first, what I always do is I decide, well, where do I want to fly? Today it's gonna be from Genoa to, where are we flying actually? Forgot where we are flying to. Was somewhere in Switzerland actually. Was it? Because I already did the flight planning. It was Genf. Don't know the English pronunciation for it, but that's in the very, I'll show you here. So we're gonna start up in Genoa and then fly to Genf, which is just at the border to France. Good. So I can already just stick on Google because first thing I do is go on SimBrief, which is a must. Like if you want to do flight planning, this is a great tool. You just create a profile for free and you can use it for free. It's great. So you just go to a new flight and then you type on the departure airport, the arrival airport. It'll give you an alternative, which is Zurich this time, but we're just not gonna fly there anyway, but whatever. This will be calculated automatically. You have to choose which airplane you're gonna use. Today we're gonna fly the A321, so that's that. And here you can use the fuel factor. Fuel factor means pretty much how efficient do you want to fly or how fast do you want to fly. The lower the fuel factor, so let's say P0 is the lowest, means that you're gonna fly as efficient as possible, but you're also gonna be slower than, as for example, if you're gonna fly with P80. With P80 you're gonna be the fastest, but you're gonna burn also the most fuel. So I'm just gonna go with P30. I don't know. I just copied that from a YouTuber, I think, and since then I'm always using P30. It's a nice number. I think some operators are using it. So the departing runway from Genoa, this will also all be calculated manually, automatically, I mean. Sometimes what I like to do is go on Flight Radar and see which runways are currently used, just to copy the real world a little bit more, to make it a little bit more realistic, but you can just leave the automatic ones. They are going to be good anyway. Passengers, I usually just put it on auto. You can just do whatever you want. You want to have a empty airplane, which is currently the case with Corona. Every airplane is empty. So realistically, you should go with empty airplane right now, but I'm just going to go on auto. Cargo, you can also do whatever you want. And it'll automatically calculate a flight plan for you. You can modify it, like sometimes. This is a SID, by the way. So if you don't know how to read this, it's pretty much first, as I said, it's a standard instrument departure, um, which you'll always follow after, like on big airports always have SIDs and stars. It's like a standard departure route that you have to follow with like speed limits and altitude limits that you have to consider. And then this SID will just lead us straight to Gen, which is a waypoint. From Gen we will take an airway. This is the M729 Airways. I'll show you here. This is maybe better. This a program I use, Navigraph. So this is kind of like the Autobahn. Because I'm German, we use Autobahn. This is like the Autobahn of the sky. So this is the sit I was talking about. We're gonna fly. This is actually a pretty funny sit, which I'll go over later on. So we'll fly this sit to Gen, as you can see here, Gen, and then we will take from Gen, we will take the M729, which is a highway, which crosses some waypoints. As you can see, Devox, Tonda, blah blah. But we'll take that to our star, which is here. So putting in an airway pretty much is just simplifying the whole input data, because you don't have to import Devox, you don't have to import Tonda. You just say, I want to go from Gen, take the airway M729 to our star, and that's it. That's all you have to input. And then from our star, we take the L615 to Banco, which is here. So that's, in theory, you don't need an airway for that, because it's just, there's nothing in between, but whatever. And from there on, we already start the standard standard arrival procedure, standard arrival to, where are we flying again? Genf, exactly. Sorry. So yeah, and that's the standard arrival. It's gonna be an on-off arrival, so that's just every airplane that takes this arrival just needs to fly this, and they're like, uh, here you, for example, this one is you have to be above flight level 100, or here you have to be maximum of 250 knots. But we'll go over this as and reach when we reach the set actually, and we'll go over this again. And after a standard arrival, you'll have we will land at runway 04, and usually it's going to be, at least in big airplanes, an ILS or an on-off approach to the runway, but we'll go over this as soon as we reach our approach phase. So, but this is going to be the flight plan. It automatically calculates it for you, so you don't have to do anything, which is nice. So then you click on generate OPP, which I already did, and it will give you this big thing, which we will go over in just a minute. So let's get rid of this for now and start the airplane. So first things first, what you want to do is turn on the batteries of the airplane. Now what you want to do, because batteries they don't provide enough power to the airplane. So what you need is an external power source, which is the GPU commonly. So you go to plugins to Tolus, open, this is like the Tolus little interactive simulation control system, as it says here. And you want to activate the external power. Usually it's activated, but I manually move the airplane, so that's why it got disconnected. But you just activate the external power, and you'll see here external power is available, so you press that, and the plane does now have power, which is great. So what I do next is you want to turn on the ADAS, which are, you want to turn them all to nav. Usually you do it just one by one. You always align one, wait until the on-bed is gone, and then you turn on the next one. What this does is pretty much, in just a second when the self-test is gone, you'll see that the map is unavailable. This will just calibrate the map, you position on the map, like GPS wise, it will calibrate it, just, and so that the system knows where you're at. And this will usually take a couple of minutes. Here you can see IIS align in over 7 minutes. So we definitely have to wait until the alignment is done before we move the plane at all, because if we move before the alignment is done, we have to start over again with the alignment at least. So what I want to do next is just turn on all the screens on max brightness. I heard that at least in older Airbuses, I don't know about new ones, but in older Airbuses, pilots always, after each flight, had to turn those down because, what the fuck was that? Because if they did not do that, sometimes the lights would burn through, and that's not good. That's not a good thing. So to make the redundancy better, the lifetime of the lights better, they always had to dim them. So each time you start the airplane, you always have to increase the brightness, which is okay. So next thing I usually do is just turn on the fuel pumps, because you need fuels for your engines later on. Um, this was just some communication thing. I think it's a backup communication. The main communication devices are these for the captain, and this for the first officer. So what this does is pretty much here you tune in the frequencies, like for ground, for tower, for center, or for ATIS. ATIS is gives you weather information and tells you which runway is in use and which runway is for departure, which runway is for taking off, stuff like that. So you want to turn those on in order to communicate with everyone. Also, what you want to do is turn on the strobe lights to auto, nav lights to auto. So strobe lights on auto, and nav lights to 1. Nav lights are those little thingies. Um, 1 and 2, this is exactly the same, but it's just 2 light bulbs right next to each other. So if one fails, you can just switch to the other one, and then the other one lights on. So it's just like, again, redundancy. It's just to make sure that there's always light working, because if they fail, it sucks. So I heard that what usually pilots do is whenever the captain is flying, nav 1 is on, and whenever the first officer is flying, nav 2 is on, just so that they both get equal time of use, kind of. So those are on auto. This is on 1. Seatbelts, you want to turn them on. No smoking to auto, and emergency exit lights to arm. If you have below, I don't know, 150 or something passengers, I don't know the exact number, but we are definitely above that. If you have below that amount of passengers, you want to turn on the econ flow, but because that's not the case today, because we will have 205 passengers today, which, by the way, SimBrief tells you, since I put it on auto, we don't use that. Also, what we want to do now is, here you can see the conditioning. Currently we have 32 degrees in our cabin and 30 degrees in our cockpit, which is way too high. And I don't even know why it's that hot in here, because outside temperature is 14 degrees. But we really need like cold air in here, so we need air conditioning, which we can do by activating the APU. The APU is the so-called third engine of the airplane. The airplane has this engine, and a really small engine right in here. Thanks to the external power, we can turn this one on, and this will provide us with all the electricity we need, so we can disconnect the external power, which is usually a cable connected to the airplane, which is not modeled here, but whatever. So this will get, we can use all the power, like the APU will give us all the power we need, and also will give us access to air conditioning. So as you saw, I put on this one, and you usually turn it on and wait until you get the flap open message. But I often saw people just directly turning it on anyway, because it's just like a little self-test. And now it will slowly start, and you just wait for it to start. Maybe you can even hear it. See, the smoke comes out. It's like the butt of the airplane. um, So yeah, you wait, you can monitor it, you can just not monitor it, doesn't really matter. Uh, Usually I ignore it, I just wait until it's available. Um, yeah, so APU is now available, so what we'll do next is just turn on APU bleed. This will give us access to our air conditioning. So let's put this on cold since it's freaking hot in here. And let the airplane cool down for a bit. So, what do we do next? What I do next is use this little nice system here. This is the FMC, FMS, whatever you want to call it, Flight Management Cockpit, Flight Management System, Flight Management Computer, I don't even know, something like that. What you want to do is go on initiate and type in your route. Today we go from, let's quickly, I can show you, I already, I have the SimBrief thing on my tablet, which is, by the way, this is AviTab, this is a plugin, you definitely need to download it, it's the best. So here I see everything I need to know. So today we're going from Lima India Mike Julia to Lima Sierra Golf Golf. So from Genoa to Genf. So we're just gonna type it in LIMJ So LIMJ and LSGG. Yep, LSGG. You can put the alternate and we can just put the alternate and it doesn't really matter, but we just do it for the sake of it. Flight number, we just go with, we're currently flying Alitalia. I don't know their call signs, to be honest. So I'm just going with Al Italia, just a random number, 1, 2, 3, 4. Doesn't really matter at all. Cost index, as I said before, it's going to be 30. The cruise level for today, we can just go here, and this is the first page. Cruise level will be 300. So you just put in 300. It'll automatically tell you the temperature, that altitude. You can double check with SimBrief, but who cares? Next thing I like to do is here you have the exact position in terms of lateral and longitude. I like to, because this is not super accurate, I think it's just the general coordinates for the airport that we're at. So I like to monitor the GPS and double check like 44249, 44247. So we just have to go 2 up. Longitude is 008510, 008505. So just go 5 up so that they match, and then I align the ILS. That's it. But we still have to wait 1 minute. So next, I like to put in the zero fuel weight CG and the zero fuel weight and the block fuel. The way we do this is a combination of using the FMS and the interactive simulation control system of Tolus and that little SemBrief thing. It's getting kind of tight in here. So 205 passengers, what we said today. You can see that here on the third page. 205 passengers and zero fuel weight of 70.8. Currently we are at 70.7, so I just added a little bit of cargo. Perfect. Apply these load settings. And the block fuel will be, you can see it on the first page. It'll tell you what amount of fuel we need for what. So the trip, which will be around 43 minutes, we need about 3.2 tons and all kind of other stuff. But in total the block fuel will be 8.3 tons, so we just go with 8.4 tons, apply, refuel, defuel. So now we have the zero fuel weight CG of 27.7%, so we put in 27.7 and a slash, as you can see here, and the zero fuel weight of 70.8. You want to make it look like this, and then right in there. And the block fuel, 8.4 tons. That's it. Now you see a bunch of numbers. For example, you have extra amount of fuel of 3.6 tons, which is great. Then I want to do the flight planning. So you pretty much just press on flight plan and just copy this flight plan. It's as easy as that. So first we need to put in the departure set. So we just do the left click onto the departing runway and press on departure. Today we'll use runway 10 and the set is to Gen 7K. No transitioning, and then we click on temporary, insert flight plan, and there we go. At the same time we can just monitor this and put it on flight plan. So this is the SID. And next from Gen, which is here, we take the airway M729. So we left click on Gen, put in the airway, which is the M729. M729. This will go to our star. So just do this and 2. Next, L615. Lima 615 to Bangkok. Insert. Sometimes you do not have an airway, actually a lot of times, so it will just say direct DCT and then the airway point. So what you do is just type in whatever airway it is and click next to flight plan discontinuity and it'll just put it in. That's it. So from there on we have our star and our approach to Gen. So we just left click our arrival airport, click on arrival, and we will take the ILS 04 via Bangkok 3N, and the VIA is always something you need to consider, which you can pretty much just check by entering the LSGG, that's the arrival runway. Our arrival is the Bangkok 3N, which will lead us to Indies. So our VIA is simply Indies and no transitioning. Insert. So we will probably have a discontinuity now. I think so. Yep, that's a manual because the air traffic control will, when we do the SID, the arrival, it just goes here and then a manual, then it'll just go straight on forever, because what the arrival chart tells you is that no turn onto base unless cleared by ATC. So ATC will at some point tell us, okay, you're cleared for ILS, turn right heading, blah blah blah. So, but because we don't have ATC, we will just delete that and insert so that we can just go straight into this. So we just kind of assume that ATC will exactly at this point clear us for the ILS. Good. So what I do next is just click on the first waypoint to the right, access wind data, and just request the wind data for our climb, and press on next phase and then the cruise wind at Tonda. This is stuff you don't need to do, but I just like to do it for the sake of it. So to kind of figure out what the cruise wind will be, I just go back to my SimBrief page, go next page, and here you have all the waypoints that you're going to cross. And I just check here, I'll reach 300, flight level 300, and the wind will be 24 knots from 42 degrees. So 042 at 24 knots. Great. Next thing you want to do is perf. This is the performance page, which will give you V1, VR, V2, flaps information, and flex to temperature information. I'll go over this in just a second. So what we're going to do is open the tallest menu, and here's the takeoff performance page. So I believe we will be able to take off the flaps 1, right? Yeah, perfect. So we go flaps 1, and here it automatically calculates you V1, VR, and V2. So you pretty much just dial in those numbers into those windows. Perfect. Flaps will be 1 slash down 0.1. 1 slash down 0.1. So after we pushed back, we will just simply select flaps 1, and this is the trim for the aileron, I believe. We will just trim this down to 0.1. What the trim does is simply, how do you explain this? It simply kind of calibrates your flight controls so that you have to use minimum amount of force onto your flight controls. That's pretty much what it does. But it's a little bit more complex than that, but yeah. So, and the flex temperature is 37. Flex temperature is pretty straightforward. When you take off, you don't want to use full thrust unless it's really needed, because full thrust will hurt the engines over time. It will reduce the lifetime of the engine. So therefore, you want to use just as much as you need in order to make sure that the lifetime of the engine is as long as possible, but also to ensure that the takeoff will be as safe as possible, or as safe as needed. So let's quickly, the flex temperature says, so I think I remember correctly, is that the flex temperature is the temperature you tell the engine there is outside. So the engine will act as if it was 37 degrees outside. So the higher the flex temperature, the less thrust it's gonna produce, if I remember correctly. So yeah, that's what the flex temperature is. The flaps, if you're really new to flying, that's just Uppsala. That's just simply these things. That's the flap. But I think you kind of know about this already. So, what's happening? I can't get out of here. So the V1 is the speed at which you can still, like before V1, you can still abort the takeoff. After V1, you always take off and do the necessary procedures afterwards, like in case of an emergency. At VR, you rotate, so you put backward pressure on the column, pull it, and the airplane's nose goes up. And V2 is the speed, if I remember correctly, it's the speed at which it's safe to fly. That's important because sometimes SIDs give you, like in general, it's important to know that you should not go below that speed when you're flying. But it's also good to know, for example, sometimes there are SIDs that are just meant for smaller airplanes, so they give you like max speed of 150. So you definitely know I will not be able to fly below 150 knots because my minimum speed is 161 to fly safe. Transition altitude is something quickly I have to explain. Transition altitude is referring to the Q and H. Q and H is measuring the air pressure or air density, whatever, outside. So on the ground, or in general, air pressure always changes. So And what the airplane does with air pressure, it measures at what height you are. Like the airplane does not look at the bottom and looks down and sees, okay, the ground is 0 feet away, because right now we would have 0 feet, but as you can see, we have 100 feet. So we are 100 feet above the ocean. It's pretty close to the ocean, because as you can see, we are at the ocean. But if you're, for example, if you're in the mountains, this can be at like 4,000. So you're at the ground, but you're at 4,000 feet. So QNH uses air density, and the air density on changes all the time. So you always need to keep this up to date, because if you don't, this will give you false information, because it's calibrating according to those informations. So let's quickly check what is the QNH of our airport. We can get rid of this actually. LIMJ QNH of 1028. So there you go, QNH 1028. And at 7,000 feet, we just press standard, because in cruising altitude, you want to have every airplane. Oh, it's getting cold in here, I see. Because on cruise level, or like at a certain altitude, you want to have every plane calibrated at the same QNH. Because let's say someone starts in, I don't know, in New York, and he starts, there's the air pressure is like 133, and someone starts in France, and his QNH is like 1007. And you want to give them altitudes to be at, so, but they both are on a completely different altitude, because they have different QNH. But if they do just go on standard, they both have the same altitude shown on their display. So that's pretty much what QNH does. So this, and at 7,000 feet we will just press standard. This is the thrust reduction acceleration altitude, so at 1,530 feet. So we first get our, this is actually, shouldn't be here. So at first, when we take off, we will put our thrust levers to flex. This will put them to flex temperature 37. And at 1,530 feet, we will put the thrust to climb. This will give us the most efficient climb rate for our fuel factor. Yeah, that's what it does. So that's all you need to know about this one. And yeah, flap retraction, so at 159, if we were flaps 2 for example at 159 knots, we could go to flaps 1, and at 215 we can go to flaps 0. So let's keep going. So what are we, where am I now? So let's quickly go to airport. So we are currently parked here, and we want to get to runway 10. So what we'll do, we'll just push back like this, facing west. So what I use is a plugin called Better Pushback, but you also can just use the Tolus pushback, which is also possible. But I highly recommend pushback, because it's just the greatest pushback system there is. Oops, accidentally. So you can pre-plan it. I already flew here. So facing east, we just want to push back like this. I just like to put it back a little bit so that the pushback doesn't mess up.
Alright, Captain, got the directions. Let me know through the menu when you're ready.
Okay, I will. So what I do next? Actually, we can already call him, to be honest. And when you call the pushback,
Great news, Captain, your tow's coming.
turn on your beacon light, which is the red warning light. And you also want to put your transponder to XPNDR, if I remember correctly. A transponder is just for... So when you line up on the runway or when you're flying, you want to have it on TARA, so that in case you come close to another airplane, you will both get a warning, and it will tell one airplane to go up and the other plane to go down. So this is really important. It makes sure that you will not collide mid-air. It's like emergency. If you collide in mid-air, this will tell one plane to go up and one to go down. So the
Alright, looks like the doors and hatches are closed and we're ready to connect.
So loud. Yeah, connect. Now it's connecting. Let's see if I forgot anything. So let's quickly go to our departure and quickly check what's our initial climb. I do not see a initial climb. Initial climb is telling you to what altitude you are allowed to climb without ATC's allowance, but usually ATC gives you...
Welcome aboard, Captain. Toes connected, bypass pins inserted. Go and kill the parking brake when you're ready to go.
Usually ATC gives you like an initial climb altitude. We'll just set it to 7,000. Doesn't really matter because we'll just go straight to cruise altitude anyway, but yeah. So we are connected to the pushback vehicle, which means, as he said, we can kill the parking brake. But before we do that, something I forgot, of course, is we can disconnect the external power. We could have done that already a long time ago. And also do this. So quickly checks everything is okay. Looking good, looking good, looking good, looking good. So yeah, pushback.
Here comes the pushback. Light them up.
Going a little bit crazy. What is he doing? Yeah, sometimes... What the heck is he? Yeah, I don't know. It's with the A321, it's sometimes bugged out a little bit. It has never been this bugged. Oh, what the heck is he doing? What is he doing? Oh no, oh, everybody's dead. So we're just gonna ignore that. Before that I was always flying the... Before that I was always flying the Zibo 737, and it worked perfectly every time. With the A321, things are not working as they should, but that's okay. We'll just ignore that. So where was I at? Yeah, we can actually start the engines now. So in order to start the engines, you want to start the ignition. And here you see we have pressure. Pressure is provided by the APU bleed. So whenever you have no pressure, you know that you do not have activated the APU bleed. And we need pressure in order to activate the engines. So starting the engine is pretty straightforward. You just usually start engine number 2 first, which is the right engine. You just do this. That's it. That's all. And now it'll start rotating. That's all there is. By the way, sound is really low. Increase it a little bit. Like if I put it on max volume, you will not hear me at all. I already tested that. It's just terrible. Also because... Let's quickly talk about this one. So we will start runway 10. We'll go straight. We will make a turn at 1.6 dme from GSE or 3 dme from SES. You can do... Actually, what we can do, I can show you a little function of the Taurus, which is a really nice function. Before I do that, engine 1 is available, so... Do you hear that? That was the barking of the PTU, by the way. The PTU is a hydraulic system, so every time, whenever you're flying with an A320, A319, 20, 21, I think they all have it. Whenever you're flying with one, the PTU will do a self-test. So you first start engine number 2, which provides the yellow hydraulic system. And when you start engine number 1, the PTU will do a self-test. PTU is actually an emergency hydraulic system which will provide hydraulic power to hydraulic system number green, to the green hydraulic system in case, for example, engine 1 fails, so that you still have the green hydraulic system. So the PTU, whenever you start the airplane, the engines, it'll do a self-test. So when you sit in the airplane next time, just whenever you hear like the you will know this is the PTU. This is not anything bad.
Just about done here. Go ahead and set your parking brake.
Yes, sir. We will set the parking brake. So both
And we're disconnecting the tow. Give me just a moment.
both engines are on, so we can now put this to norm. Great, great, great. Actually, since we have now power, as you can see here, we have now power via the generator 1 and generator 2 from the engines. We don't need the APU anymore. We don't need the APU anymore, so we can just turn the APU off. Perfect. What's the time right now? I don't wanna... Yeah, just leave it. Whatever. I don't want to land when it's too dark. That always sucks. So where was I at before?
And we're disconnected. Signal and pin on the right. Take it easy and have a safe flight.
Exactly, I wanted to show you this function. So, since we may have to make a turn at 3DME SAS, which is the VOR, we can just go here, click anywhere, oops, on the left side, fix info, enter the VOR SES, and put a radius to 3 nautical miles. So now, you see this blue little circle? We have to make a right turn exactly at the edge of that circle. And we have to have a max speed of 185 in turn. So we can quickly check with our flight plan if we consider that. So we consider a speed of 185, but if I guess correctly, it'll only have 185 until that point, and then it'll increase speed. So we don't want that. We want to keep 185 until we're done with the turn. So I'll manage the speed manually, to be honest, afterwards. Good. And then we just make a little right turn and fly a little circle, and then we cross the Gen VOR. We do this little crazy move, which is not usual. It's quite special actually. Usually it's just go straight and make a left turn or something. But we do this because the mountain is too high. Like you cannot just fly left over the mountain. I think it would work, but probably not safe. Not safe enough, at least. So yeah, and we always have to make sure that we cross those altitudes at certain heights. Like we are above 4,500 here, above 5,500 here, and above 9,000. Above one of those flight levels over here, which we will manage easily. This one just flies up so fast. So, what's up next? We're gonna turn on the taxi light. And we are going to... This is the ECAS. It'll tell us what we need to do before taking off. So, before taxiing, we actually put auto brake on max. Arm the spoiler. Put the flaps to takeoff, which is 1. They go down here. And yeah, for taxiing that's enough. And as soon as we reach the holding point is this point, right before the runway. As soon as we reach the holding point, we'll just inform the cabin that they should be ready by now, and we can make a takeoff config test just to make sure everything is perfect. Put this on perf and this on flight plan. Turn on the weather radar, at least on the co-pilot seat. Turn that brightness a little bit down. And also at the holding point we will turn on the weather radar. And we will also lock the door so nobody can enter us and kidnap us. Good. So let's go taxi. So we can just get my controller real quick, my joystick, and release the parking brake. And we'll just taxi straight across Echo 1. Increase our thrust to about 30% N2. That's enough for sure. We'll put on the constraints. It will just give us a little bit of more information about the constraints that are active. Also, we can quickly check our flight controls. They all seem to work perfectly, as expected. Also, before I forget, since this is a tutorial video, I will deactivate any emergencies, because that would suck right now. This is our ground speed. In case you want to know how fast you're on the ground, you can just check here. Usually I think there's a speed limit of 50 knots on the apron. Not sure though. So we'll make a right turn here onto Alpha. Continue taxiing until the very end of the runway. I'll put this to 20. This is also a plug-in terrain radar. It's great. It really is great. So maybe tell the cabin now that they should get ready. Yep. Also, you can go over all these systems. This is the engine system. You can just take it. It's alright. This is the bleed system, conditioning, some cabin pressurization, electricity, hydraulic systems, fuel. Currently have 8.24 tons. The APU, which is off right now. Air conditioning. The doors. The wheel. The flight controls. This is the status page in case anything is not working or you have to consider something. This will pop up here. And yeah, currently we have the wheel thing on because I don't know why, to be honest. So so caution ILS lock antenna. So typically I think you have to stop here in order to not block the ILS antenna. I already heard of incidents where planes actually crashed because the ILS system was blocked, and when landing you need that. You really need that. So if it's blocked, the ILS will just throw you off the runway or something, like just lead you somewhere wrong. So you never want to block that. Okay, we're almost at the runway. So we'll just turn on the landing lights. Nose light to takeoff strobes on.
Approaching 10.
To takeoff config test. Put this on weather radar on, even though we don't really need it today. And I think that's it. Open this. Make sure we don't forget to keep
On
185
runway
knots.
10.
So, aligned on the runway. Everything looks good. Everything looks good. Okay. Takeoff. So, what we do, we slowly increase thrust to about 50% N2. Look if the engines are stable, they are. And go to flags, which is here. You see here, man flags 37. We put a little bit of forward pressure here on the column, so we have a little bit better control. 80 knots checked. 100 knots. I'm going to turn on the timer maybe, just so we know how long we've been in the air. We can release the forward pressure to 100 knots actually. B1 and rotate. Okay, positive climb, gear up. Just make sure that we put this on manually 185. So now we go to thrust climb. Since we reached the 1500 something. Always try to follow the flight directors, which are those green arrows. So it's pretty easy actually. Beautiful. Just beautiful. Whoops. So we are about to leave the turn, so just go back to manual to automatically managing the speed. So now you see our max speed is 250 because below 10,000 feet airplanes are only allowed to fly 250 knots. At least it's usually the case. Whoopsie. So let's turn on the autopilot. And as soon as we reach the airspeed, we can go flaps up. Okay, flaps up. Put back the spoilers. And inform the cabin crew that they can move their asses around. Turn off the runway lights. Oh, and one thing we forgot to do. TCAS on TIRA. Oh well, that's how it is. So as you can see, for some reason we're not perfectly on that line. Don't know why, but that's just the case. So we'll just buck this up to 30,000 feet. So let's see, what else can I tell you about the departure? So those are the VORs. They always have a certain frequency in the Airbus. You can just go to red and just dial in whatever VOR you want. So currently both frequencies are on 112.8 Gen VOR. This will point towards that VOR, which is over there. And also you'll have this one pointed there. So we crossed 7,000 feet, now we can put the QNH to standard. So yeah, that's how you put in the VOR. And if you come to an ILS frequency, so if you want to land on an ILS, this is usually automatically done by the airplane. It automatically knows which ILS you're going to be using, so it automatically dials in the ILS. But in case it's messed up or something, you always want to double check. You can just manually dial that in here. So that's all about the departure. Actually, we can close this one for now. And we're about to reach 10,000 feet. At 10,000 feet, our speed restriction will be gone, so we can increase our speed, which will be happening automatically. And what we can also do is turn off the landing lights and turn off the seatbelt signs. You don't have to do it at 10,000 feet, but I think that's pretty calmly done, just deactivating in at 10,000 feet. So now everybody can walk around in the plane, because we have such a full plane of 205 passengers. Why can we not move around right now? Oh, I think, oh, okay, that's why. So, as you can see, oh, it's locked, right? Oops. As you can see, our full plane of nobody. Actually, I've never seen it. That's really nice. How they designed the interior of the Alitalia livery. That's nice. That's really good. Because I usually fly the Lufthansa livery, and the inside just looks ugly. Honestly, just ugly. Go back to locking. Just imagine flying this one in real life. So, maybe increase the distance a little bit. Where's the airport? So let's see, what can I explain here? It's not much at the moment. So I'll probably cut the video here and see you back when I'm gonna be approaching the descent phase, because that'll be interesting again. So until then, see you later.